Hello there, mathematicians. Today's objective is Objective 116C, and that is students will be able to calculate percent of change. Okay, I'm really excited about this lesson because this is actually the first year we have done this lesson. It is something that we discovered our juniors on the ACT were struggling with. So we're going to include it in our freshman objectives so you guys can practice it all 3 years. And it's also a very real life objective. You can apply this to your real lives now and all the way through adulthood. So let's get started. First of all, the percent of change. So we can abbreviate here, percent of change. Okay, is simply, and you guys are writing this in that space in your notes. Let's see, it is the percent increase or decrease of one number to another number. Okay. Now, here's what you gotta remember. You gotta remember this. To figure out percent of change, it is simply this. It's the change over the original. And then it's a percent. So get that through your mind. Percent of change is change over original. Change over original. And then to convert it to a percent, we simply times by 100. Okay? So, in other words, this is simply the change. How do we figure out the change in between two numbers? Well, we simply find the difference of numbers over the original number, or you could sometimes say the starting number. So, we may have problems that says like you start off with, $20, you now have $14, what percent did your money change? Well, the starting number is our denominator in this case. Okay, let's go on to examples. Alright, this says, state whether each percent change is a percent increase or decrease, then find, I should say find with a D, each percent change. Okay, with these problems, it is so important to do a sanity check and to start by just using common sense, okay? So the first thing that we're going to do to help us think about this in terms of real life, so draw number 1 over here to the side, is, let's just say know whether increase or decrease. And you may think, well, yeah, that sounds simple. Okay, if you rush on these, you're going to circle sexy distractor answers that say the answer was an increase. Well, you're going to circle the same number that's a decrease. So know that ahead of time. Okay. All right. So let's look at example 1. Okay, the original number was 25. The new one is 28. So is that an increase or a decrease going from 25 to 28? Now, you better say it's a percent increase. So right now, I'm going to just start the answer. I know it's going to be some number and then a percent increase. So say that was like 10%. The answer, we'd just fill in the blank and say like 10% increase, and we'd circle it. In fact, let's just circle this now, because this is going to be where we put our answer. Okay. Now, when it gives you the original and the new amount, to find that the change, okay, it oftentimes works really well to start off by having the new number So let's start with the numerator. Remember, it's the change over the original. Well, how do we figure out the change? We subtract. And in this case, we're going to do the new number minus the old, or the original number, we could say. So the new number was 28, the original number is 25, and we always put it over, remember it's the change over the original. Change over the original. And then we got to just times it by 100. Okay. So 28 minus 5 is a positive 3. Oops. I should actually change this. We're filling in numbers here. So go ahead and erase yours. You should be using pencil. We put it over the original number, which in this case, the original number was 25, right? So you end up with 3 over 25 times 100. And when you get that, you're going to get a 12% increase. Okay. All right, let's do example 2. Okay, we have an original number and a new number. Well, is it getting bigger or smaller going from the original 30 to 12? It's getting smaller, so we're just going to write percent. Is it an increase or decrease? It is a decrease. Oops. Okay, and let's circle this. We're going to have some number in there, but we know that the answer is a percent decrease. Okay, so we're going to do the new number minus the original over the original. Remember, it's the change over the original. How do we figure out the change? We subtract. Okay, and then we're going to multiply it by 100 to get a percent. Okay. 12 minus 30 gives us, what would that be? Negative 18 over 30 times 100. Okay, do that on your calculator. And we should have gotten a 60% decrease. Okay. Now, when you got that, you got negative 60, right? Okay, what do you think this negative tells you? It confirms that it's a what? It confirms that it's a decrease. Okay. But I think it's best to always just look at the original numbers and say, is it getting bigger or smaller? Okay. All right, you guys set up your work and do practice 1 and 2. So again, hit pause, set up your work, and do it. Okay, you should be done with these 2 problems now. So the answer to the first one is a 46. First of all, I know it's decreasing, so you should have done that sanity check. Again, the sanity check is part of CUPS. Make sure your answer makes sense. 46.6 repeating. Okay, show that exact answer repeating, percent decrease. Okay. Now we could also say 46 and 2/3% decrease. Okay. All right, practice 2, you should have gotten the answer of, and again, if you don't have it, okay, do it now. And if you got one wrong, make sure you mark it wrong, the practice 1. That way you know when you're studying for the test to go back and really correct the ones that you missed. Okay, the next one, it's clearly an increase. Okay, from 45 to 89 is increasing. That's a pretty big increase. It's almost doubling. Okay, and here's something you got to know. If something's almost doubling, what percent does it increase by? Well, it pretty much increases by the original number, so that would be 100% increase if it doubles. So we know our answer has to be close to 100% increase, and in this case, it's 97.7% increase. Okay. Alrighty, let's do a word problem. Okay, a class has 20 students. Okay, and it increases to 25 students. Okay, increase. Find the percent of increase. Okay, anytime you're talking a percent increase, a percent decrease, a percent of change, what percent did it change? Anytime you hear or read those key words, you got to be thinking percent change, which, what's going through your head? It is the change over the original. Okay, so the change Again, we're going to start off with the new if it gives us kind of a new and an old. So we could do the 25 minus the 20. The original number it had, right? That's what it started with. So that's what tells us that's original. Now, one of the most common mistakes in this objective is when students don't put the correct original number as a denominator. You have to find the starting or the original number. And that number in this case is 20. Okay? So that would be equal to 5 over 20. And then we're going to times it by 100 to get to a percent. Okay? And that, I believe, gives us, and we should have written it over here to begin with. That's will help us with the sanity check. But it gives us a 25%, and we see that it's increasing. Okay? And then it told us, like, find the percent increase, so it had better be an increase. Okay? Alright, I think we'll do example 2 in class, so let's go on to the next page. And let's start down here. These practice ones we'll do in class. I just want to cover the essentials here. So this next part is find missing value given percent increase or decrease. Okay, so instead of having two numbers given to us and we have to find the percent, now we have one number and 1% given to us, the increase or decrease, and we have to find the other number. Okay. Now I'm going to teach you two ways of doing this. And then I'll talk about which method I personally think is the best. Okay, so let's read this first one. NFL fields are 120 yards long. Canadian fields are 25% longer. Okay, what is the length of the Canadian football field? Now, if it's 25% longer, we know that this has to be more than 120. Okay, now you guys, on a test, on a multiple choice test, I would put money that there will be answer choices that are less than 120 yards. Right now, before going any further, if you were taking a multiple choice test, just cross those out. Those are insane answers. It's saying the Canadian field's longer than the 120. Okay? So, let's go through this. I want to show you two methods. So let's write this first one as method 1. Okay. Now, 120 yards was the starting, right? Okay, if it's getting longer, are we going to add or subtract yards? Well, we're clearly going to add. Okay. Now, how do we show 25% longer? Here's the key to think about this. 25% longer than what? 25% longer than what? Well, it's 25% longer than the original 120-yard field. Okay, so how would we find 25% of the 120 yards? We would simply do 0.25, because we take that percent, the 25%, divide it by 100. So if you need to show that, go ahead and show that. Divide it by 100. And then it's, again, 25% of the 120. Okay, so if we look at this equation, and basically we're writing an equation on this, we have 120 yards plus, because it's getting bigger, okay, 25% of what? 25% of the 120-yard field, the NFL field. Okay, and when you do that, you would get, and again, you can plug it right into your calculator exactly the way you see it. Just make sure you use parentheses, and you're going to get that the Canadian field is 150 yards. Okay. Now, I'm going to show you a second way of doing it, and this is using what we learned today. Okay. Let's start with, I don't know if it'll let me. Okay, here's the other way. Okay. We're going to use the formula that we learned today, which is the change over the original. Okay, so we're going to start off by doing the bigger number to figure out the change, the numerator, right? We're going to, in this case, we're going to do the bigger number minus the smaller number. Now, which number is bigger, the Canadian or the NFL field? Well, it's the Canadian. Okay, so let's just call it the Canadian field, C. When we subtract the 120, okay, NFL field, the American field. Okay, the starting field that we had was 120 yards, right? That's what we knew. Okay, and then we would have to times it by 100, and that would equal the 0.25. Again, let's look at this. If we do this C, okay, the C minus 120, the change over the original 120, and times it by 100, it tells us that it should be the 20, that should say 25%. Okay? Again, this time we have the percent given. We're just trying to find a number. Now, the first thing that we would do to solve this equation would be to divide by 100. Divide by 100. Okay, and that's going to leave us with C. I'm going to rewrite this, I think, in red. That way you can see a little bit better. So we have the C minus 120 over 120 is equal to 0.25. Okay. How would we solve this equation? Well, because the side with the variable, C, right, everything is being divided by 120. So we're going to undo that first by times by 120 over 1 times by 120. Okay. 120 in the numerator, 120 in the denominator is going to cancel, leaving me with, and I'm going to show my work down here. Hopefully you guys have a little bit more work than space than I do, because I have to write a little bit bigger. That would leave us with C is minus 120 is equal to 30. Okay. And then to solve for C, C minus 120, how would we solve for C? Well, we would have to add 120, add 120. Okay. And you get C is equal to 150. Okay. You notice you get the same thing using both methods. Okay. The first method is kind of writing an equation. The second method is using the percent of change formula. Okay. Let's go on and do example 2 quick. Ooh, these other numbers are floating around now. That's weird. Alright, hopefully you have those in your notes. Let's get started on example 2. Okay, the average attendance at a high school football games was 2,000 people in 2003 and decreased 25% by 2005. What was the attendance in 2005? Well, right away, let's do a sanity check. Is it going to be more or less than 2,000 people? Okay, and you should say less than 2,000. Right? It tells us right here it's a decrease, so we've got to have fewer people. Let's use method 1 by writing the equation. Okay. Well, we started with 2,000 people. Okay, we have less, so we're going to what? Add or subtract? Hopefully you said subtract. Okay. Now, we lost 25%. But again, 25% of what? Okay, and in this case, it's a 25% of the original number, the 2,000. So to figure out what that is actually as a number of people, not just as a percent, we got to do 0.25, because we just did 25% divided by 100, 0.25 times 2,000 people. Okay. Okay, when you do that, you get 2,000 minus, if you just do this, you get 500 people. Okay, so that's going to give us a grand total of 1,500 people. And we should say, let's see, that was in 2005. Okay, that's our answer. Now, let's do method 2. We have got to work. When we graded the OERs for all the students, it was scary to see how unorganized most students' work is. Okay, we take pride at Pritzker in being the most professional, the hardest working, the smartest students. Part of that is being able to show that. And if your work's a hot mess, you're not showing that you understand things very well, or that you're very professional in the way you show it. Okay. And it's hard. I know you're probably judging me right now. You're probably saying, look at your work. It's hard drawing on this iPad, okay? So, let's do method 2. If we do the bigger number minus the smaller number. So what number is going to be bigger, the 2003 or the 2005? And hopefully you said the 2003 number, which was 2000. So if we do 2000 minus, let's just call it the x, because we don't know what the new one is, over the original 2000. And that's going to equal, now I could have shown here, you may be saying, well, why didn't you times by 100? And then, well, we know we'd have to divide by 100. So I'm just going to convert this 25% to a decimal right away, which when I divided by 100 first up above, that's what it would have done anyway. Okay. Now, this entire side with the variable is all, so the left side of the equation is all being divided by 2000. So therefore we can undo that first by multiplying this entire left side by 2000. 2000 in the numerator, 2000 in the denominator cancels, times by 2000. Because again, whatever you do to the left side, you have to do the exact same thing to the right. That leaves me with 2000 minus x is equal to 500. Okay. Now we got to solve for x. What's being done to x? Well, we have a negative 1 touching it, but we also have this positive 2000 hanging out over there. So we got to get this positive 2000 to the other side by subtracting 2000. Leaving me with negative 1x is equal to 500 minus 2000 would be negative 1500. Okay. Well, we can't leave a negative x, so we got to divide by negative 1, divide by negative 1. Anytime we're dividing or multiplying by negative 1, it just changes the sign. So we get the same thing. X is equal to 1,500. Exact same answer as before. Okay. All right, when we get to class, we will practice a lot more of these. But make sure you go back, look at your notes before you come to class. And you got to come to class prepared and ready to practice these right away.